Imagine standing on the surface of Mercury, the closest planet to the Sun, where temperatures soar to a scorching 800 degrees Fahrenheit during the day. Now, picture the breathtaking beauty of Venus, shrouded in thick clouds of sulfuric acid, with a surface hot enough to melt lead. As we drift outward, Mars beckons with its rust-colored landscapes and the tallest volcano in the solar system, Olympus Mons, towering 3 times higher than Mount Everest. Jupiter, the giant of our solar system, spins with a storm known as the Great Red Spot, a tempest larger than Earth itself. And don't forget Saturn, adorned with its stunning rings made of ice and rock. Beyond the gas giants lies the icy realm of Uranus and Neptune, where winds howl at over 1,200 miles per hour. Each world tells a story, a testament to the wonders of our cosmic neighborhood. The solar system is not just a collection of planets. It's a breathtaking tapestry of extremes and mysteries waiting to be uncovered. The Sun, a glowing orb of plasma and energy, reigning supreme at the center of our solar system. It's a blazing giant that provides the energy necessary for life on Earth. Yet it remains a mysterious and powerful force. With a diameter of about 1.39 million kilometers, the Sun accounts for 99.86% of the total mass of the solar system. This immense mass generates a gravitational pull that keeps everything from tiny asteroids to massive gas giants in orbit. The Sun is primarily composed of hydrogen, which undergoes nuclear fusion in its core, producing helium and releasing an enormous amount of energy. This energy radiates outward, giving us the warmth and light essential for life on Earth. At the core of the Sun, where temperatures reach a staggering 15 million degrees Celsius, hydrogen atoms fuse together to form helium, releasing energy in the process. This energy slowly travels through the radiative zone, where it takes thousands of years to reach the convective zone. Here, currents of plasma carry the energy to the surface, where it's finally released as sunlight. But the Sun is more than just a source of light. It's a dynamic, ever-changing body. Solar flares, which are sudden eruptions of energy, can release as much energy as billions of hydrogen bombs. These flares can even disrupt communication systems on Earth and pose risks to astronauts in space. And then there are sunspots, dark, cooler areas on the Sun's surface that appear in cycles, peaking every 11 years. But the Sun isn't just a solitary star. It's part of a vast network of stars in the Milky Way galaxy, each with its own system of planets and celestial bodies. While we orbit the Sun, it too is moving, traveling at a speed of 220 kilometers per second around the center of our galaxy. This journey will take our solar system about 230 million years to complete one orbit around the Milky Way, a cosmic year. Now, let's journey to the planets closest to the Sun, the rocky, terrestrial worlds of Mercury, Venus, Earth, and Mars. These planets are characterized by solid surfaces, and each has its own unique environment and history. Our first stop is Mercury, the smallest planet in the solar system and the one closest to the Sun. With a diameter of just 4,880 kilometers, Mercury is only slightly larger than Earth's moon. But don't let its size fool you. This little planet endures some of the most extreme conditions in the solar system. Due to its proximity to the Sun, Mercury experiences scorching temperatures that can reach up to 430 degrees Celsius during the day. However, because it has virtually no atmosphere to retain heat, temperatures plummet to minus 180 degrees Celsius at night. This stark contrast makes Mercury one of the most inhospitable places in the solar system. Mercury's surface is covered in craters, evidence of a tumultuous past filled with asteroid impacts. One of the most striking features is the Caloris Basin, a massive impact crater over 1,500 kilometers wide, created by an asteroid collision nearly 4 billion years ago. Despite its harsh environment, Mercury is a fascinating world that offers clues to the early days of our solar system. Next, we move to Venus, often referred to as Earth's twin because of its similar size and composition. However, Venus is far from being Earth-like. Its atmosphere is a dense, toxic soup of carbon dioxide with clouds of sulfuric acid, creating a runaway greenhouse effect that makes it the hottest planet in the solar system, with surface temperatures soaring above 470 degrees Celsius. The thick atmosphere also means that Venus experiences crushing pressures, over 90 times that of Earth's. It's a world of volcanoes, with vast plains covered in hardened lava. The planet's surface is young, geologically speaking, with evidence of recent volcanic activity, though no active volcanoes have been observed directly. Venus also rotates in the opposite direction to most planets, meaning the sun rises in the west and sets in the east. And one day on Venus lasts longer than a Venusian year, 243 Earth days to complete one rotation and 225 Earth days to orbit the sun. This retrograde rotation and thick atmosphere make Venus one of the most intriguing and hostile places in our solar system. Of course, the third planet from the sun is our very own Earth, the only place we know of that harbors life. Earth's unique position in the solar system, combined with its atmosphere and magnetic field, creates the perfect conditions for life as we know it. Our planet's surface is 71% water, earning it the nickname the Blue Marble. This abundance of water, along with the right temperature range and a protective atmosphere, supports a diverse array of ecosystems and life forms. But Earth isn't just a static backdrop for life. It's a dynamic planet with shifting tectonic plates, active volcanoes, and a constantly changing climate. The interaction between the atmosphere, oceans, and land shapes our weather patterns and geological features, from the tallest mountains to the deepest ocean trenches. Earth's atmosphere, composed mostly of nitrogen and oxygen, protects us from harmful solar radiation and regulates our climate. The magnetic field, generated by the molten iron core, shields us from the sun's charged particles, creating stunning auroras near the poles as a byproduct. Yet, despite its life-giving qualities, Earth is not immune to cosmic hazards. Asteroids, solar storms, and even changes in the sun's activity can pose threats to our planet. As we continue to explore space, understanding these threats becomes crucial for the long-term survival of life on Earth. Beyond Earth lies Mars, the red planet, named for its rusty, iron-rich soil. Mars has captivated human imagination for centuries, with its potential to harbor life, its striking landscapes, and its similarity to Earth. Mars is home to the tallest volcano in the solar system, Olympus Mons, standing 22 kilometers high, nearly 3 times the height of Mount Everest. It also boasts the largest canyon, Valles Marineris, a system of canyons stretching over 4,000 kilometers across the Martian surface. Though Mars is a cold, desert world with temperatures averaging minus 80 degrees Celsius, it has polar ice caps made of water and carbon dioxide. These ice caps grow and recede with the Martian seasons, which are similar to Earth's due to its axial tilt. However, a Martian year is nearly twice as long as an Earth year, lasting 687 days. Mars has long been a target for exploration, with numerous missions revealing signs of past water flow and potentially ancient life. As we continue to study Mars, it remains a prime candidate for future human exploration and possibly even colonization. Beyond Mars lies the asteroid belt, a vast region filled with rocky debris left over from the early solar system. This region is home to countless asteroids, ranging in size from tiny pebbles to dwarf planets like Ceres. The asteroid belt is a relic of the solar system's formation, a place where material that never coalesced into a planet continues to orbit the sun. These space rocks offer valuable clues about the building blocks of planets and the history of our cosmic neighborhood. Ceres, the largest object in the asteroid belt, is a dwarf planet with a diameter of about 940 kilometers. It's large enough to have been rounded into a sphere by its own gravity, and it even has water ice beneath its surface. Ceres was the first dwarf planet to be visited by a spacecraft when NASA's Dawn mission arrived in 2015, revealing a world with bright spots of salt deposits and a thin atmosphere. The asteroids themselves come in a variety of shapes and sizes, with some being rubble piles loosely held together by gravity, while others are solid rock or metal. They represent a treasure trove of resources, including water, metals, and other materials that could be crucial for future space exploration. Yet the asteroid belt isn't as densely packed as often depicted in science fiction. While there are millions of asteroids, they're spread out over a vast area, making collisions relatively rare. However, the potential threat of asteroids to Earth is very real, with ongoing efforts to track and study near-Earth objects, NEOs, that could pose a danger to our planet. As we venture beyond the asteroid belt, we encounter the giants of the solar system, Jupiter and Saturn. These gas giants are massive worlds, composed primarily of hydrogen and helium, and they're surrounded by fascinating systems of rings and moons. Jupiter, the largest planet in the solar system, is a true giant with a diameter of 142,984 kilometers, more than 11 times that of Earth. It's so massive that it contains more than twice the mass of all the other planets combined. Jupiter's immense gravity has shaped the solar system, influencing the orbits of asteroids and even protecting Earth from potential impacts. Jupiter is known for its banded appearance, with alternating belts of clouds and storms, the most famous being the Great Red Spot, a colossal storm larger than Earth that has raged for centuries. Jupiter's atmosphere is a turbulent mix of hydrogen, helium, and trace gases, creating powerful storms and intense radiation belts. But Jupiter isn't just a gas giant. It's also a mini-solar system with 79 known moons, including the 4 largest, known as the Galilean moons: Io, Europa, Ganymede, and Callisto. Io is the most volcanically active body in the solar system, with over 400 active volcanoes spewing sulfur and lava. Europa, on the other hand, is an icy world with a subsurface ocean that might harbor conditions suitable for life. Ganymede, the largest moon in the solar system, is even bigger than Mercury and has its own magnetic field. Callisto, heavily cratered and ancient, is a window into the early solar system. These moons, particularly Europa, are prime targets for future exploration, with missions like the upcoming Europa Clipper set to explore its potential for life. Next, we arrive at Saturn, the second largest planet, and perhaps the most visually stunning. Saturn's rings are a breathtaking sight, composed of countless icy particles, ranging in size from micrometers to meters. These rings are divided into several main sections, each with its own unique characteristics, and they extend over 120,000 kilometers from the planet's surface. But Saturn is more than just its rings. It's a gas giant with a diameter of 120,536 kilometers and an atmosphere rich in hydrogen and helium. Saturn's low density means it would float in water, if such a massive body could ever find such a vast ocean. Saturn also has a diverse family of moons, with 83 known satellites, the most famous of which is Titan, the second largest moon in the solar system. Titan is a world shrouded in mystery, with a thick, hazy atmosphere of nitrogen and methane, creating a landscape that's eerily reminiscent of Earth, with rivers, lakes, and even seas, though these are made of liquid methane and ethane. Beneath its icy crust, Titan may harbor a subsurface ocean of water, adding to the intrigue of this distant world. Saturn's other moons, like Enceladus, also hold surprises. Enceladus, a small, icy moon, has geysers that shoot water vapor and organic molecules into space, suggesting a subsurface ocean and the potential for life. Beyond Saturn, we encounter the ice giants Uranus and Neptune, 2 planets that defy expectations and challenge our understanding of planetary science. Uranus is a planet of extremes, with an axial tilt of 98 degrees, meaning it essentially rolls around the sun on its side. This extreme tilt results in unique seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Uranus is an ice giant, with a diameter of 50,724 kilometers, and its atmosphere is composed mostly of hydrogen, helium, and methane, giving it a blue-green color. Uranus also has a faint ring system and 27 known moons, the largest of which are Miranda, Ariel, Umbriel, Titania, and Oberon. Miranda, in particular, is a bizarre world with a fractured surface featuring giant canyons, terraces, and cliffs, making it one of the most unusual moons in the solar system. Uranus's tilt and unusual magnetic field, which is also tilted and offset from the planet's center, make it a fascinating object of study. However, Uranus has been visited only once by Voyager 2 in 1986, leaving many of its mysteries yet to be uncovered. Finally, we arrive at Neptune, the farthest planet from the Sun and the most distant of the ice giants. Neptune is slightly smaller than Uranus, with a diameter of 49,244 kilometers, but it's a dynamic and active world. Neptune's deep blue color is due to the presence of methane in its atmosphere, but it's the planet's weather that truly stands out. Neptune has the strongest winds in the solar system, with speeds reaching up to 2,100 kilometers per hour. These winds power massive storms, including the Great Dark Spot, a storm similar to Jupiter's Great Red Spot, though it appears and disappears over time. Neptune also has a collection of 14 moons, the largest of which is Triton, a frozen world with geysers that spout nitrogen gas and a surface that suggests it was once geologically active. Triton is unique among large moons in the solar system because it orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit. This unusual orbit suggests that Triton may have been captured by Neptune's gravity long ago, and it may have originated as a dwarf planet in the Kuiper Belt. As we leave Neptune, we reach the outer edges of the solar system, where the Sun is just a distant star and the temperatures plunge to the coldest extremes. Beyond Neptune lies the realm of the dwarf planets and the Kuiper Belt, a vast, icy region filled with small, frozen bodies that hold the keys to understanding the outer solar system. Pluto, once considered the ninth planet, is now the most famous of the dwarf planets. Discovered in 1930, Pluto resides in the Kuiper Belt, a region of the solar system beyond Neptune that is home to countless icy bodies. Pluto's diameter is just 2,377 kilometers, making it smaller than Earth's moon. Yet, this distant world has captured our imaginations with its unique features. The New Horizons mission, which flew by Pluto in 2015, revealed a surprisingly complex world with mountains of water ice, plains of frozen nitrogen, and a thin atmosphere. One of Pluto's most striking features is the heart-shaped region known as Tombaugh Regio, a vast plain of nitrogen ice that suggests ongoing geological activity. Pluto's surface also shows evidence of cryovolcanoes, volcanoes that erupt with ice instead of lava. Pluto has 5 known moons, the largest of which is Charon, a world half the size of Pluto itself. Charon and Pluto are locked in a gravitational dance, with each showing the same face to the other, a phenomenon known as tidal locking. Charon's surface is a mix of icy plains and canyons, and it may also harbor a subsurface ocean. The Kuiper Belt is a vast, donut-shaped region that extends from just beyond Neptune's orbit to about 50 Australian dollars from the Sun. It's populated by a multitude of icy bodies, including dwarf planets like Haumea, Makemake, and Eris. Haumea is unique for its elongated shape and rapid rotation, spinning once every 4 hours. This rapid spin has stretched Haumea into a football-like shape, making it one of the most unusual objects in the solar system. Haumea also has a ring system, the only known ring around a dwarf planet. Makemake, slightly smaller than Pluto, is known for its reddish color and lack of a significant atmosphere. It's another example of the diversity of objects in the Kuiper Belt, each with its own story to tell. The Kuiper Belt is the frontier of the solar system, a region where the Sun is just a bright star in the sky, and the temperatures are so cold that even gases like nitrogen and methane can freeze solid. It's a region that challenges our understanding of the solar system's formation and evolution, and it's a place where future missions will continue to explore. Far beyond the Kuiper Belt, at the very edge of the solar system, lies the Orion Cloud, a distant, spherical shell of icy bodies that surrounds the Sun at a distance of up to 100,000 Australian dollars, nearly a quarter of the distance to the nearest star. The Orion Cloud is the source of long-period comets, icy visitors that occasionally venture into the inner solar system, creating spectacular displays as they pass close to the Sun. These comets are remnants from the early solar system, preserved in the deep freeze of space for billions of years. The Orion Cloud is so distant that no spacecraft has ever come close to it, and its existence is inferred from the orbits of long-period comets. It represents the final frontier of the solar system, a region where the sun's gravity is weak and the influence of other stars becomes more significant. As we wrap up our exploration of the solar system, I can't help but marvel at the incredible diversity of worlds we've encountered. From the fiery storms of Jupiter to the icy plains of Europa, each celestial body tells a story of its own. The gas giants loom large, while the rocky planets remind us of our own earthly home. And then there's the enigmatic Orion Cloud, a vast realm of icy bodies that hold secrets yet to be uncovered. Imagine the potential for life lurking beneath the icy crust of Titan or the subsurface ocean of Europa. These moons ignite our curiosity and challenge our understanding of what life could be. The solar system is not just a collection of planets. It's a dynamic tapestry of extremes and beauty, constantly inviting us to explore further. Every mission we embark on peels back another layer of mystery, revealing the wonders of our cosmic neighborhood. The more we learn, the more questions arise, reminding us that the universe is full of surprises. The journey doesn't end here. It's just the beginning of our quest to unlock the secrets of the worlds that dance around our sun. Thank you for joining us on this journey through the solar system. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more amazing world facts. Until next time, keep exploring the wonders of the universe